Hello friends, welcome to another episode of Rough Series. Today we are going to look at a very important topic. Today we are going to look at the visual field of the eye, as well as a very important clinical correlation called the bitemporal heteronymous hemianopia, otherwise called tunnel vision. Stay tuned as we go through this. This is a diagram of the eye. What you see here is called the visual field. Now, before we go through anything, I would just like us to go through quickly the names of whatever we see here on the diagram. So what we see here is the visual field. So this could be an object that is sending light rays into the eye. These are the eyeballs. And then what you see here is called the optic nerve. This is called the optic chiasma. You have the optic tract going to the lateral geniculate body, synapsing in the lateral geniculate nuclei, and then moving to the calcarine gyrus of the brain. Good. We are going to look at the visual field of the eye. But then before we start that, let's first look at some very important terms. Now, we are going to look at a term called hemifield. The field of the eye is generally what the eye can see. But a hemifield, just like when we have a sphere, when we take half of a sphere, we get a hemisphere. So if this is a field, and we take half of the field, then we have a hemifield. Good. So the eyeball has very important features just allow us to see. One we are going to look at very well here is the retina. So light rays from the eye will come and then will be absorbed by the photoreceptors that are located on the retina. Now, we have two sides of the retina, as you can see here. We have this side. If this is a human being facing this way, then this will be the lateral side and this will be the medial side for the left eyeball, and this will have the medial side and then the lateral side for the right eyeball. Now, this portion is the retina. So the right side of this eyeball is the left eyeball. The right side of the left retina perceives a hemifield that is described here. The total field that is perceived by this eyeball is what we see in the short dashed line circled area. The visual field that is seen by this eyeball is what we see in the darker circle. But they all come together to give us a big circular structure forming the entire visual field of the eye. Now, when we take the right eyeball, the left side of the retina of the right eyeball perceives a hemifield that is towards the lateral side, and then the right side of the retina of the right eyeball perceives a hemifield that is towards the left side. So, from what we learned here, we will say that the right side of the retina of the right eyeball perceives what? A hemifield that is towards the left side. So we say left hemifield. Why hemifield? If this is the entire visual field perceived by this eye, half of it, as we saw here, is the hemifield. So this right side of the retina will perceive this field, this hemifield here, and the left side will also perceive this hemifield here. So in total it gives us the dark colored area. So also when we go to the left, the right side of the retina of the left eyeball will perceive this visual field, and then the left side will also perceive this visual field. So in total, we have a field that is noted by the short dashed lines. Now remember, the fields are also divided into quadrants. So we have a green quadrant, we have a blue quadrant, a red quadrant, and then a black quadrant. As you can see here, the black quadrant, the green quadrant, the red quadrant, and then the blue quadrant. As much as the visual field is divided into a hemisphere, it is also divided into quadrants. So just like we saw for the left and then right eyeball, about the size of the retina and then what they perceive, the quadrants also work that way. So the lower portion of the retina will perceive light rays coming from the upper quadrant, and then the upper part of the retina will perceive a visual field that is in a lower quadrant. Now, this is the visual field. So we go to a simplified diagram of how the retina perceives the visual field. So just like we analyzed here, we will realize from here that let's take the right eyeball as a case study. Realize that the left side of the retina of the right eyeball, otherwise called the nasal side because this part will be closer to the nose, perceives a peripheral area. So we can see it perceives this area, but then realize that there is a central area and then there is a peripheral area. Let's take note of that. Now, the right side of the retina, otherwise called the temporal half of the retina, because it is more located when we look at the head of a human being, this part will be towards the temporal region, also perceives a central area. So while the medial side of the retina perceives a peripheral field, the temporal side or the lateral side perceives what? A more central field, which is here. That will be very important when we come to talk about tunnel vision. Now, this is a simplified diagram of how the right eyeball perceives its field. So as you can see here, now this right side is perceiving here. So when we bring it here, we are talking about this side. So what is seen by the temporal part of the retina, or the photo rays, the light rays that come to the temporal part of the retina of the right eyeball, is what we see here. Remember, we established that this visual field is what the right eyeball sees, the darker stained region. Good. So the right side perceives a hemisphere that is described here. Now when we pick it up, this is what we see. We said that, so what we see here is actually on the retina. So we can see clearly that this hemisphere, you can see that the colors are inverted. Here it was blue in the lower quadrant and then red in an upper quadrant. But when we come to perception on the retina, we said that the lower quadrant of the field is perceived at the upper part of the retina. So that is what we see here. And then the upper quadrant of the visual field is perceived at the lower part of the retina. That is what we see here. And this is the visual field captured by the temporal half of the retina of the right eyeball. Now let's come to the medial side. Now for the medial side, we realize that the field is the hemifield is here. So realize that the temporal part is towards this side. Now, unlike what we saw when we were looking at the visual field perceived by the temporal part of the retina of the right eyeball, which is here, the part of the retina that is towards the nasal side, is that okay? Which is the medial part. So the nasal part of the retina to perceive an eye field that is more peripheral. So we have this, rather that there is a central part and then there is a peripheral part. So this is what is perceived. This area is what is perceived by the nasal part of the retina of the right eyeball. So this is the peripheral part we are seeing here, but again, the upper and then lower quadrant will be inverted because that is how the retina perceives it. And then we have a central part and then a peripheral part. Now that we have gone through this, take some time to see whether you can analyze this part yourself. Good. Now that we've looked at the visual field, so the nasal side of the retina of the right eyeball is picking information from a temporal hemifield, or a hemifield that is towards the lateral part. And then the lateral part of the retina of the right eyeball is picking a hemifield that is more medial, or that is more nasal. So look at the difference here. Temporal part of retina of right eyeball picks a hemifield that is medial. Nasal part of the retina of the right eyeball picks hemifield that is lateral. Good. So after the light rays are absorbed by the photoreceptors, which are the rods and cones, we know that the information is eventually given, or we must have read, but if you haven't read, then let's learn it now. The photoreceptors will synapse on bipolar cells, and bipolar cells will in turn synapse on ganglionic cells, and from the ganglionic cells we have the optic nerve. So what we see here is the optic nerve, but then the information is going to come or go through the optic nerve according to how it was taken from here. So at this point, the green color represents the info that was picked up from the retina of the right eyeball, and then this represents the info that was picked from the left eyeball. So let's just look at one part, which is the green part. Then you can analyze this side yourself as an assessment. Good. So this is info, impulses. Let's say if this is the nerve, this is the impulse going through the optic nerve. But you realize that the portion that comes from the medial side or the nasal side of the retina crosses, but then the portion that comes from the temporal side remains on the ipsilateral side. Now we see that also here. So the nerves coming from the medial or the nasal part of the retina are going to cross. Now it creates a chiasm here we call the optic chiasm. So from the optic nerve we go to the optic chiasm, and then we form what we call the optic tract. So the optic tract of the right side is formed by nerves that arise from the temporal part of the right eyeball. Okay, the retina, the temporal part of the right eyeball, and then nerves that are coming from the nasal side of the retina of the left eyeball, coming together to form the tract, and then move on to what we call lateral geniculate body. Since we are talking about side, L is light. For the lateral geniculate body, L, always remember that We have another one which is the medial geniculate body, that is for auditory. Auditory nerves will synapse there in the nuclei that is located there before they move on. So remember, music for sound, and then light, lateral geniculate body for vision. So from the lateral geniculate body, the fibers will now move to the occipital lobe and then to the calcarine gyrus. Good. Now, this is the visual field of the eye. Now, let's look at a very important clinical correlation. Now, there is a case where sometimes tumor, the pituitary gland, when the pituitary gland becomes cancerous, it can become so big it compresses the optic chiasm or the optic chiasma. What happens? If there is a lesion here, there is a lesion to this side, we are going to see that since the fibers that cross are fibers from the nasal side of both eyeballs or both sides of the retina, you have the left and then the right. So the nasal side of the right, of the left retina, and the nasal side of the right retina, those are the fibers that cross. So if there is a lesion to this part, the tumor grows and then breaks up this part, it's going to affect light rays that are actually reaching the medial side. And then let's compare that to the eye field. What do we observe? Now, let's look at the visual field of the nasal side. You realize that the visual field is, for the right, is here. And then for the left, we have it here. So if there is a problem, that affects the nasal side, what are we going to observe? It will affect the visual fields at the lateral side. So we say bitemporal. So the visual fields are the temporal fields. So we say bitemporal. Now, this is a problem that is going to affect both sides of the eye. So we say it is what? Heteronymous. If it were the same, it would have been homonymous, but it's both sides because it's affecting the optic chiasm. So we say it's heteronymous. And then when you have a problem with the nerves and you can't see very well, it is called anopia. But in this case, it is only affecting half of each side. So we say a hemianopia. So why then do we call it tunnel vision? Now let's see something interesting. If you are losing impulses that are coming from the medial side of both sides, that means that you can only perceive things that are catered for by the lateral or the temporal house. So we can only see this area, even though it's overlapping, but we are not viewing what is going to the nasal side. So that means that we are going to have loss of peripheral vision. So there will be loss of peripheral vision this way. The peripheral vision will be lost this way. So we have loss of peripheral vision. So you see, the information that will now be reaching the eye will be those that are only from the medial hemifields going to the lateral or the temporal house of each of the retina. So your vision appears to be what? Tunnel. That is why we refer to a bitemporal heteronymous hemianopia, also as tunnel vision, because your vision is now like you're looking into a hole. So you see something like a tunnel vision. Very soon we have come to the end of another session. Thank you very much for having time for me. Till I see you next time. Bye.